Yeah, very good morning, my dear students. So, today let us discuss the phases of compiler. As discussed yesterday, compiler is a translator which converts a high-level language program to a low-level language. So, basically, whatever the high-level language code is there, we feel that it is directly converted into a low-level language by a translator, basically, right? Among these translators, you have multiple. That is, you have compiler, we have interpreter, we have assembler, we have even macros are a part of your translators. Preprocessors are also a part of translators. So we'll discuss one by one what are all these language translators. So starting with a compiler, right? So as seen in the program, that is when you run a program, when you go for a compiler, given an input in a high-level language, we are getting the output in a high-level language. So it is not as well as directly converting a high-level language to a high-level language. In between, it will be converted from high-level language to a low-level language, where the machine can understand it. Then from the low level language, it is again converted to a high level language where a human can read it in a human readable form. Okay. So it is something like a translator is acting as a mediator where it converts the high level language program to a low level language, and further the low level language program is converted to a high level language. Okay. So the first thing, how does this process goes on in a compiler? So it is not a single step process. When you go for a single step process, we call it as a pass. That is, a single execution of an entire program is called a pass. But when you go for a phase, then you can clearly understand how exactly the conversion is taking place. Okay. So now let us discuss the phases of compiler. The phases of compiler, what each phase is taking as an input and what processing is being done in the phase and what will be the output of that particular phase. Okay. So I have totally 6 phases of compiler. Starting with lexical analysis phase. The first phase of the compiler is lexical analysis phase. The second phase of compiler is syntax analysis phase. The third phase of compiler, semantic analysis phase. The fourth phase of compiler is intermediate code generation. The fifth phase is code optimization. And the sixth phase is target code generation, or simply I can call it as a code generation. Okay, so the first phase is the lexical analysis phase. The second phase of the compiler, syntax analysis phase. The third phase of compiler, semantic analysis phase. The fourth phase of compiler is intermediate code generation. The fifth phase of compiler is code optimization. And the last sixth phase of compiler is the code generation, where the target code is being generated. Right? Now, along with these 6 phases of compiler, you have another 2 components involved in the phases. One is symbol table manager. Symbol table manager or symbol table management. And the other component is error handler. Error handling, or you can call it as an error handler. Okay. Now, these two parts, the symbol table, these two components, the symbol table manager and error handler, will be in communication with all the phases of compiler. Will be in communication with all the phases of compiler. So let us see how these phases works individually. So let us start giving the input. Okay. So basically, when you write a program, when you write a C program, say for example, let me give a simple statement like C equal to A plus B into 10. Let me take a simple C programming construct. C is assigned a value of A plus B into 10, where A, B, C are real values, or let me call them as floating point values. Okay. So let me declare three variables A, B, C, and let me store, or let me assign a value of C as A plus B into 10. Okay. Now, before seeing how this particular statement is passed on to these phases, now let me first tell you in general what are the different terminologies being used for every phase. That is, what is the input provided to every phase, what is the processing being done in the phase, and what will be the output of that phase. Okay. So, the input to lexical analysis phase, which is the first phase of compiler, will be the input stream. The input stream, or you can call it as the source stream. The source code. Okay. So once the input is provided, the source code is provided, it passes on to the lexical analysis and gives you tokens. Gives you tokens. Okay. And once tokens are passed on to syntax analysis phase, it will give you a syntax tree, and more specifically, we call it as parse tree. Parse tree. Okay? And the parse tree, after passing on to the semantic analysis phase, you get a semantic tree. Okay? And after that semantic tree being passed on to the fourth phase, which is intermediate code generation, then here comes the intermediate code. So the intermediate code is being generated. Now after the intermediate code being generated, then we go for optimizing the code using the code optimization phase. So the outcome of code optimization will be the optimized code. Fine. And after the optimized code being passed on to the code generation phase, then you get the target code. So you are starting with the source code. You are starting with the source code, and finally ending up with the target code. Okay. Now once the target code is being reached, this target code will be used by the compiler to convert our input and pass it on as an output. So whatever the input is being provided by us to the compiler, that will be passed on to the target code. Okay, and then we get our required output. Okay, so this is what the processing is being done. So now we will further go in detail. What are all these terminologies one by one? Okay, so the first one, source code. Let me take the example as the statement. C is assigned a value of a plus b into 10. So let me take this as a source code. C is assigned the value of a plus b into 10. Okay. Now, when this particular input string is being taken, then the functionality of the lexical analysis is to convert the given text into parts, which you call them as lexeme. You call them as lexeme. The given input string will be divided into parts. Okay, so a decomposition is being done, and each and every individual part you call it as a lexeme. Okay, so now in what way it is being given? So after the conversion of lexeme as parts, then it will identify what kind of token it is. Okay, now you must have a basic knowledge of what do you mean by token, which you might have studied in your first year. Can anyone tell me what do you mean by token? Yes? You can give your own definitions, no problem. What do you mean by token? Am I audible, all of you? Yes. Yes, tell me, what do you mean by token? Yeah. The smallest individual particle of a program is called a token. Okay. So you have the various kinds of tokens. You have keywords, identifiers, constants, strings, symbols, operators. Okay, so these are all the tokens. Now, when you are going for scanning the input, see, always remember the input will be scanned from left to right. Okay, so whenever the scanning process is started from the first character, so it is having a character C. Now immediately it will not come to a conclusion, then goes for the next character. Now the next character is a symbol, so now it is being divided. Okay, so now it is one lexeme. Now similarly, you have an equal to symbol, then goes for the next character, so it is alphabet again. So again this is another lexeme. So likewise, you have A as another lexeme, plus as another lexeme, B as another lexeme, star, which is a multiplication, as another lexeme, and a constant 10 as another lexeme. So this particular division is being done by the regular expressions being provided by the languages. Now you need to have an idea of formal languages automata theory, which you have studied in the previous semester. So the regular expression being provided by the language. Now what do you mean by regular expressions? Regular expressions will come up with the functions, how the definition for all these tokens are provided. Say for example, if I go for keywords. Now keywords, let me take an example of for keyword. Now for keyword must have, from the starting state, it has to go for F, then it has to go for O, then it has to go for R. Now this will be the final state. Now like that, for each and every keyword, for each and every identifier, for each and every constant, strings, symbols and operators, you'll be having a finite automata design. You'll be having a finite automata design, and accordingly you'll be having a regular expressions. You all know for every finite automata you have a equivalent regular expression. Okay. Now, if at all you have operators, now what are the list of operators? You have 14 levels of operators, starting with the unary operator. First you have the parenthesis, then you have unary operators, you have the size of type definition, then comes the arithmetic operators, then you have bitwise operators, logical operators, okay, and the last ending with comma operator, right? So the parenthesis, the array operators, size of operator, type definition operator are the highest precedence operators, where comma operator is the lowest precedence operators. So likewise, a list of all these operators are being stored in an array, and a comparison is done with the operators first. Okay. Now, if at all it is not an operator, then it goes for the array of symbols. Now we have some symbols like semicolon, which represent the end of the statement in a program, right? And you'll be using hash symbol, which is for the pre-processing techniques. So likewise, you have some symbols being defined. So then it goes for checking the presence of symbols. Fine. The latter it goes for checking the strings. Strings, you know, a sequence of characters ending with a null character. So it goes with respect to the memory allocation and checks whether it is a string or not. Then it goes for checking the constants. So constant can be a global constant or your predefined constant, whatever being done in the program. And after that, it goes for checking the identifiers. So identifiers are nothing but, so let me just go for an order, a change in the order. Later it goes for checking the keywords. Then finally, if it is not matching with any of these, then it goes for identifiers. So after constant, it goes for checking whether it's a keyword or not. So what do you mean by keywords? You have a list of keywords. Like in the earlier version, you have 32 keywords. The latest version of ANSYS is coming up with 34 keywords. Okay. So it just goes for comparing with all those keywords. Now, if it is not matching with that keyword, then finally it identifies it as an identifier. Identifiers are nothing but the user-defined names. So it may be a variable name, it may be a function name, it may be a procedure name. Okay, so it depends on the program. In some compilers you call it as a program procedures, in some compilers you call it as a functions. Okay, so likewise, finally it takes a decision. So accordingly, now the C is being categorized as an identifier. Then you have equal to, which is nothing but an assignment operator. Then you have A, which is nothing but an identifier. Then you have plus, which is nothing but an operator. Excuse me. Excuse me, students. Then you have plus, which is nothing but an operator, addition operator. Then you have B, which is nothing but an identifier. Then you have multiplication, which is an operator, and 10 is nothing but a constant. So likewise, all these leximes are being divided, and you come up with the tokens. Now these tokens will be the output of the lexical analysis phase. Okay. So whatever the input string, the source code being taken here, now this will be represented as C is an identifier. So it takes as ID 1 and equal to, since it is an operator, assignment operator, it is being taken as it is. Then A is another identifier. So already I got one identifier which is ID 1. So now it takes it as ID 2. Right? Next, you have a plus operator. Then B is again an identifier. So already I got two identifiers. So now I take it as the third identifier. Next, multiplication, which is nothing but an operator. And then 10 is nothing but a constant. So it remains the same. Now, once the tokens are being identified after the first phase of compilation process, then starts the operation of symbol table manager as well. Now, what is the symbol table manager? The symbol table manager will maintain the entries in a symbol table. Now, the symbol table, say for example, just let me take an entry serial number and what is the lexeme, what kind of token it is, what is the initial value, what is the default initial value, what is the memory allocation or memory storage being done, and what are the operations that can be performed on that value. So likewise, all these entries are being stored in the symbol table, so which is maintained by the symbol table manager. Okay, so let me take the lexemes now. So the first one is, I have taken it as C lexeme, which is an identifier, which is ID1. Then you have an assignment operator. So let me take it as an operator. Then let me take A, which is an identifier 2. Then let me take plus, which is an operator. Then let me take B, which is ID3, and then multiplication, which is an operator, and then 10, which is a constant. Okay, so likewise we have all the entries being maintained. So totally I am having 1, 2, 3, 4, 5, 6, 7. 7 lexemes being present as per my current input stream. Okay. Now after these tokens are being passed on to syntax analysis phase, then the outcome will be a parse tree. Okay. What does the syntax analysis does? The syntax analysis considers the lexemes and tokens which are provided as output of the lexical analysis phase. Now this is passed as an input to this phase, syntax analysis. So the role of syntax analysis language. Syntax of the language means the rules of the language which you are considering. Then it goes for arranging these in a hierarchical order. So which you call it as a parse tree. It arranges whatever the input, whatever the output obtained here, that is provided as an input to the syntax analysis phase. Now this it arranges in a hierarchical order, which you call it as parse tree. Now what is that hierarchy? How do you get that hierarchy? So as I told you, you have all the operators starting from the level 1 to level 14. Okay. So now I am having the operators assignment, plus and multiplication. Now which is having the highest priority? Assignment plus, that is addition, and multiplication, which is having the highest priority?
Multiplication.
Yeah, very good. Multiplication. So multiplication has got the highest priority. So first I need to go for a multiplication. Okay. So now let me go for the parse tree here, where I go for a multiplication. And what are the, see, multiplication is a binary operation. Okay. So I am multiplying ID3 with a constant 10. So I take the left argument as ID3 and the constant 10 as a right argument. Okay. Now this particular processing is being done or represented in a hierarchical fashion. Right. Now next, after that I am having assignment and plus. So which is the highest priority operator among these two? Assignment and plus. Yes? Yeah, plus. Very good. So plus is the highest priority operator. So let me go for the plus operation now. So let me go for the plus operation, and now this plus operation is again a binary value. So whatever the result I am getting for this ID3 multiplied by the 10, now this is to be added with ID2. Okay. So whatever the outcome I am getting here after the multiplication, that is being taken as a right argument, and the left argument I am taking it as ID3. Okay. So this will be the hierarchical structure after the addition. Now I am left out with only one operation, which is assignment. So whatever the value I am getting after the addition, now that will be assigned to ID1. Okay. Now this is the procedure how the processing is being done. Even for a simple statement like this, the internal processing is being done in this way, which is a hierarchical fashion in terms of a parse tree. So this is very, very important. Okay, which gives you the order of precedence and how the operations are being done for each and every statement in a source program. Fine. Now this particular hierarchical structure is nothing but your parse tree. Okay. Now there is a simple difference between a parse tree and syntax tree. Now what is a syntax tree? A syntax tree is a tree where we draw with respect to the start symbols of the grammar. We draw with respect to the start symbols of the grammar, which you might have already studied in the formal language and automata theory. You have come across with CFGs, context-free grammars. So context-free grammars, you are having a grammar symbol, say for example, for the same thing, whatever I have drawn, hope you might have remembered, you might have got this. E is assigned E plus T, and T is being given T star F and F to ID. Do you recollect this grammar? E to E plus T, T to T star F, F to ID, and where ID is can be A or B or C. The same thing from this grammar itself, I got this, whatever I have taken, C equal to A plus B into 10. Okay, now instead of representing ID assigned ID plus ID into 10, now I can simply represent as E plus T, T star F, and then T to F, E to T, T to F, F to A here B, here 10. Okay. So if I represent the tree structure with respect to the symbols of the grammars, which are nothing but variables. See, grammar will have variables as well as terminals. Okay. So if I represent the tree with respect to directly terminals, then it gives rise to a parse tree. And if I represent with respect to variables as well as terminals together, then it is nothing but a syntax tree. So simply I can say that parse tree is a condensed form of syntax tree. Parse tree is a condensed form of syntax tree. Fine. Now we'll discuss in detail about this parsing techniques in unit 2. Okay. Actually, the precise discussion of lexical analysis is again done in the second part of unit 1, and the discussion of syntax analysis will be done in unit 2. Okay. So right now you just have a glance. What are all the phases? Because now this will give you the overall view of your subject compiler design. Okay. Your course compiler design. Now after the parse phase is being generated, then it is passed on to the third phase, which is semantic analysis. Okay. So what is the semantic analysis? The semantic analysis is check. The name itself indicates semantic means checking the meaning. Checking, you go for a type checking, you go for the equivalence checking, okay, and you go for the compatibility checking. So all these checkings will be done at the third phase, which is semantic analysis phase. Okay. Now let us check what is the compatibility with respect to our string. Say for example, I have considered C equal to A plus B into 10 and I have defined A, B, C as the floating numbers, or let me call them as real. Okay, but now if you can observe this operation, ID into 10, ID into 10. Now this is a multiplication. Now this multiplication operation will consider the two operands which are of same type. Both the operands of the multiplication must be of same type. So now here ID3 is of real type. Now this 10 is of integer type. It is not a floating point number. It is not a real number. Okay. So what I need to do now? I need to convert this into real. I need to convert this into real. Okay. So the same parse tree will be now converted to a semantic tree by converting into the real of this constant. So whatever the constant we have taken 10, that will be converted to a real value, so that I get a real value at this particular branch, the right side of the right branch, and the left side I am already having a real value. So a real value multiplied with a real value. Now there is a compatibility. Okay. Now this kind of checkings will be done at a semantic analysis phase. Okay, and whatever the small change which is being done to the parse tree, now that I could term it as a semantic tree, because the tree is being checked with respect to the semantics of the language, and then I obtained the say for example, if there is no any changes required, if all the branches of a syntax the parse tree are already compatible, then the same tree syntax, the parse tree, will be carried out as a semantic tree. Okay. Next coming to intermediate code generation. Now, what is this intermediate code generation? Any doubts till now? Any doubts? Okay. Okay. Maybe I need to end today's class here. So we'll discuss these three in the remaining class. So let me just stop here and tell you that what are all we have discussed, the three phases of compiler. What are all we have discussed, the three phases of compiler: lexical analysis, syntax analysis, semantic analysis, along with a part of intermediate code generation. You term it as an analysis part. You term it as analysis part. Okay. And whatever the remaining part, a part of the intermediate code generation, code optimization and code generation, you term it as a synthesis part. You term it as a synthesis part. Okay. So the first three phases are coming under the analysis part, and the next three phases are coming under the synthesis part. Okay. And as I told you, after the lexical analysis phase, you get tokens, now which are being stored in the symbol table manager. And when you go for the next phases, when you go for syntax analysis, semantic analysis, and the remaining phases, whenever you are making use of those lexemes, the related information of those lexemes will be obtained from the symbol table itself. Okay, so that's the reason symbol table manager is accompanied with all these phases. Okay, now accordingly, even the error handler will take care of the errors which are being occurred at every phase. Say for example, after the lexical analysis phase, there is a chance of getting lexical errors. Now what do you mean by lexical errors? Maybe some typographical errors. Say for example, I just take INTI. I'll just write INTI semicolon. Now the compiler will treat this as an identifier. Why? Because INTI is not matching with an operator, not matching with a symbol, not matching with the string because it is not ending with a null, and it is not matching with constant, it is not matching with a keyword also. Why it is not matching with a keyword? Because there is no any space in between int and I. If it is a space in between this int space I, then int will be considered as a keyword because int is for integers. Okay. Now since int I didn't give a space because I missed it. Maybe due to my typing and all, I missed the space. Okay. So this kind of errors we call it as lexical errors. Okay. And which will be encountered, which will be immediately encountered and will be notified accordingly after your compilation process. And when you go for syntax analysis, there is a chance of getting syntax errors. Most commonly, you get these errors while doing the programs. Because, for example, when you have done your programs in first year, after the compilation process, you might have got missing semicolon, okay, or you have used plus without giving the second operand. Only one operand you have used plus and that too towards the left side. Okay, so there is a chance of getting an errors. Okay, where the description is very clearly mentioned. Now, how that description is very clearly mentioned? Because it is being handled by the error handler mechanism. Okay, so you get a syntax errors, and sometimes you even get semantic errors. Now, when do you get semantic errors? When there is a mismatch with respect to the compatibility or mismatch with respect to the type checking. Okay, so that is where this semantic analysis phase plays a role. Okay, so when one type of operand is being added with another type of operand, then you get an error. Okay, or sometimes you may get a warning also, isn't it? So these kind of errors are being handled by the error handler, and the error handling mechanism will be done mostly at the analysis phase itself, because the analysis part is dealing with the source program construct, and the synthesis part will be concentrating on the target program constructs. Clear all of you? Okay, so this is what the phases of compiler, and after the semantic analysis phase, then it goes for the intermediate code generation. Intermediate code will be generated. Now we discussed about this intermediate code generation in our third unit itself, where we concentrate on the 3 address code. Then we go for the optimized code, where we apply the optimization techniques. Then finally we get the target code. Okay. Now once we get the target code, then whatever the input we are providing at the text editor, whatever the program you are writing in the text editors, that program will be passed on as an input to this target code, because this target code is the machine readable format. Okay, so the machine will take the input, it processes it based on the target code, and then gives you the accordingly output. Okay, so this is all the phases which are being carried out during the compilation process. Is all clear, all of you? Shall I extend for 5 more minutes so that I can complete this process as well? Yes?
Okay, sir.
Okay. So, when you go for the intermediate code will be using the temporary variables, because whenever you are going for a processing, the processing will be done with respect to the temporary variables, and using the temporary variables, you use a concept of buffering. Okay, called as an input buffering. Okay, so say for example, I am storing a value into real of 10 is stored in a temporary variable, say temp1 or t1, Let me assume temp1. And what? So this is my first operation. My first operation from this semantic tree will be conversion of into to real of a constant temp. Fine. Next, what is the next one? The computation of ID3 with this value. Now this value already I am taking it a temporary variable. So I will directly take temp1 now. So ID3 into temp1, I am getting some value that I am storing it as temp2. Okay, and so this I got it as temp1. Now this I got it as temp2. Okay, now ID2 plus temp2 is stored in another temporary variable set temp3. So now this entire thing is stored in temp3. Okay, and finally this temp3 is assigned to ID1. So ID1 is assigned a value which is available in temp3. Okay, now this is nothing but your intermediate code. Okay, we'll discuss in detail about the intermediate code in your third unit. Fine. Next, now you might have observed here I have come across with 4 steps. Okay, just with a simple example of a single statement, I am getting 4 steps after your intermediate code generation. But do you feel all these 4 steps are efficient? Let us see. The first step is only converting into to real. Okay. Second step is multiplying ID3 and temp1. Third step is adding ID2 and temp2. And fourth step is only assigning the value of temp3 to ID1. Okay. So in second and third step I am doing some operation. But in the first and last step, I am only assigning the values. So only the typecasting is done, only the assigning is done. So where I can minimize these steps. I can minimize these 4 steps into only 2 steps now. Okay, I'm just directly speaking. Okay, we are just by observation we are doing it. But in the 4th unit, we go for discussion of a code optimization algorithms and procedures where we will be following a certain procedures. Okay, as of now, to have a understanding, let me minimize these 4 steps into 2 steps. Now, what are the 2 steps? I can directly use ID3 into 10.0 where I am going for an implicit typecasting. I am going for an implicit typecasting and directly assigning this value to a temporary variable, set temp1. Okay, and the other operation is ID2 plus. Now I can directly take temp1. There I used temp2 because I used 2 temporary variables earlier, but now I am using only 1 temporary variable. So let me take temp1. Okay, and now this I am assigning it to ID1. Okay, so in this way, the 4 steps are being optimized to 2 steps. Okay, so this is what is being done in code optimization phase. Okay, and finally the code generation. In code generation phase, the majority of the work is register allocation and assignment. So you need to allocate the registers because registers are the memory locations where you are storing the values of the lexinase. Okay, so thereby the processing will be very fast when you go with respect to the registers. Fine. So Now I am storing the registers, I am showing the values in the registers. Say for example, now first I have to store the value 10. So in registers, we will be using the mnemonics. We will be using the mnemonics like move flag 10.0, okay, to 10.1, right? And then multiply, or let me take the registers directly, R1, then multiply ID3. Now before going for multiply, let me move the value of ID3 to R2. I am taking register 1 for 10.0, for ID3 now I am taking the register R2. Now I want to multiply these two. So simply you write multiply R1 comma R2. So when I go for multiply R1 comma R2, the both values present in the both registers will be multiplied and the resultant will be stored in R1. Okay. Then later I will go for add the fields present in. Before that, let me move the value of ID2. Now move up ID2 to, let me say R3, and then go for add R3 comma R1. If you want the result to be stored in R3, then you go for add R3 comma R1. If at all you want the registers to be stored in R1, then you say add R1 comma R3. Okay. Now like this, the register allocation and assignment will be done at the code generation phase. Okay. So in this way, all these phases are doing their processes accordingly. So that's the reason phase is nothing but an independent task of a program which is being done at an individual level, having a particular input, a particular processing and a particular output. So there is a very clear separation of all the phases. Okay. So anyway, it's a time for your next class. So any doubts, students? Any doubts? And good that you have given good answers. So likewise, make sure that you, I told you in the previous class, the prerequisites for the compiler design is the formal language, automata theory and data structures. So once if you have a good knowledge of the formal language, automata theory and data structures, then it's easy for you to understand. Okay. So by the time we move on to the units, then I request you all to go through the prerequisites so that it is easy for you to understand. Okay. So thank you all.